Okay, we're starting, guys. We have lots to cover. So apologies for this, for the snafu. We have 34 odd participants here. This is the first webinar I am doing. Hey, Prachi, you've joined. Prachi, can you figure out how do we enable chat for everyone so people can talk to each other? Prachi is also from the Axel team. So
Yeah.
that'll be just figure that out. In the meanwhile, I'll start off with the whole session, right? So guys, for those of you who are not on, who are not in this group, we have everything at Axel AI community group. It's on WhatsApp. Please feel free to join it. This is the QR code. I'll also, let me see if I can share the invite link for all of you. And we've kept it open for anybody to join it. So please feel, I'll send it across later on to everybody. Or so Prachi, maybe you can add it, send it to the group on the chat so people can join if they want to click on. Yeah. Okay. With this, we'll start off the webinar. Today's focus is to kickstart the AI community within the Axel portfolio. Axel, for those of you who don't know, we have 180 plus odd companies in India right now. We're multi-stage investors, and most of your companies, we've been the seed or Series A investor. Like, why are we doing this? So we are doing this because I'm just right now very passionate about AI. I'm one of the partners here at Axel. I've been with Axel for the last 12 odd years. Used to work at Adobe as a software engineer, then in product marketing and then product management, and then at Standard Chartered Bank. Been with Axel for 12 odd years. I'm by no means an expert in AI, but yes, I do a lot of coding in my spare time. Not a professional coder anymore. But just passionate about it, and AI just got my fancy. So I thought it will just make a lot more sense. For the last 2-3 months, I've been deep head down into AI, and I realized it's a very exciting journey for me. And we've been doing brown bag lunches inside in Axel, and would love. I just like to build the community around it. So hopefully all of you are along, and I realize it's always. I get a kick out of doing this along with a lot of people. So what you hear is more from a VC perspective, more from a second-hand perspective, or a hobbyist perspective. And you have smarter people than me on this group who know a lot more about AI, and we are going to talk about with them today. So to kick off this journey, the whole idea is, it's a journey we are all on, and we are all on, and it's going to be enjoyable if we all share together. So please feel free to share on the group. As many interesting articles, questions you might have. That's the intent. Second is, today we have people who are experts and people who are very early. So today's session is the first kickoff session. It's more about just appetizing you about AI, different things and flavors of what I have seen, and broadening just the kind of things you can talk about in AI. So today we're going to do that. And then finally, there's a group discussion for the more slightly advanced level folks, which is fine tuning an LLM. So that again, I think the most common thing which we have seen across our companies is figuring out, okay, I understand all of this, but what does this mean for my company? What can I do really with this, right? So that's the bit which is a group discussion, and we'll try to it's a 2-hour session. It was supposed to be offline. It became online so that more people can attend. I know 2 hours online is too much, so I won't blame you if you leave out in the middle. But please stay around for the fine-tuning discussion. I'll try to run through my slides in next half an hour to 40 minutes, and then we'll just get into the discussion. And then we can have a Q&A with everyone. People can start questioning and asking questions. And I let some of you who are advanced, and if you know an answer for somebody who's asking a question, we'll get you on board, and you can feel free to ask questions on that. So I sent out a survey to all of you. Thank you for those who responded. And just so that everybody knows where everyone else is in the journey of AI. I think it'll be good for me to share those survey results. I'll quickly run through this. By today evening, around 1 hour back, I had received 30 odd responses to the questions I sent. And one of the first questions is what are the use cases people are using AI for today? Majority of those responses have dabbled with text generation. It could be through AIs, it could be through GPT. Few set has experimented with image generation. AI ops, much less. Obviously, we don't have a lot of DevOps people on the group. So AI ops is actually a part of DevOps, so much fewer. And then what was surprising for me was very few people have actually played around with LLM ops. And hopefully today's session, we're talking a little bit more about it, so people will get more aware of what LLM ops is. Maybe it's more VC speak, the VC category. And then we have some interesting folks who have played around with code analytics, text to 3D, and I'm assuming some of the folks who are doing text generation have also played around with some of these things as well. The second bit is the technical bit a little bit. So whereas everybody in their journey of understanding of AI or using the AI tools, so almost everybody has access to GPT. So most of you have tried GPT. I was expecting this to be 100% response, but I think people have also tried open source LLMs, which is great. So closed source GPT, so just so that everybody is on the same page, closed source LLM means like GPT is the most popular one from AI, OpenAI, but you have Anthropic, you have AI21, you have Cohere, and some of the other platforms which are quite popular. Diffusion models for image generation, these are Stable Diffusion, Midjourney, and DALL-E are the most common ones. And then you have prompt management. We'll talk about this as a part of LLMs, LLM ops, prompt marketplaces. We'll discuss this as well, vector DBs, and programming LangChain, programming frameworks. So if you're on the call and you haven't tried some LangChain programming, I would highly recommend you to try it. That is the best way for a programmer to start driving value out of LLM models, and it'll bring you much closer to make you much more able to utilize AI better. This was a tough one. How many of you have fine-tuned your own LLM, right? So a lot of folks have. The first question when I talk to a CEO or a CTO is, how does it work on my data? And that's where fine-tuning an LLM comes into. As you can see, 30 responses, 13.3 people, which is essentially 4 people out of 30. And actually, when I checked, it was actually 3 who had truly done this. So 3 out of 30 people have actually done a fine-tuning. And today, more people should learn about it. So we will talk about that also. And then this is the slightly more advanced folks. So where people are using AI agents, people are using Baby AGI and GPT, and so this is people who are clued into the ecosystem. Net, there's a lot to learn for all of us, and we are not all on the same boat. We are in different boats. Some are ahead, some are behind, some are just starting off, and hopefully the community is one which can help everyone learn and improve and get along. So that's the intent of this community. So yeah, with that, I'll jump into the VC, my perspective as a VC, and very quickly why I am excited. And I truly believe, you had invention of electricity, you had invention of the telephone, then you had invention of the computer, the invention of AWS cloud, and then you have the invention of AI. And these are markers of, where human productivity goes 10x, things change for the better worldwide. And AI is one such inflection point in our journey, or the ease at which AI can be used as a tool is the inflection point. And that's why we as VCs are very excited about investing in this space. So now a lot of things happening in the ecosystem. How do we look at the ecosystem, right? How do we look at it? And by the way, you please feel free to send questions in the Q&A so that, if I get any question, I can try to take it and answer that question. For VCs, there is a bunch, if you try to understand the whole ecosystem, the way it works is that you have right at the bottom, you have the compute hardware, right? So what are the enabling things are the GPUs and the TPU. So TPUs is a TensorFlow GPUs which Google has created. And the compute power of these GPUs has been increasing exponentially. So last year, the newer version of NVIDIA chips is 2x better than the last version and the like. And then a lot of the existing cloud platforms, and this is not something new, like all SaaS is built on it, have been starting to provide these GPUs for end customers. So it is becoming more en masse. But what has fundamentally changed in the last 1 year is the evolution of the algorithms, the models, which have been trained and become easier to use, and which is what a lot of you know more from GPT-3 and GPT-4, essentially, right? And obviously GPT-4 making it a consumer app where all of us have started trying and dabbled with it freely has increased the awareness about it. But there are other things which people should be aware of. Everybody on the call, I would highly recommend you should go to the model hubs, specifically, Hugging Face, where you'll see the variety of models, all the smart, interesting discussions are happening around it, where you can see latest research, you can see people discussing things at a international level, and I think that will help us expand the horizons, help us expand whatever we know. And then most of us would have played around with end-to-end apps, which have becoming more consumer facing, like a Mid-Journey for drawing things, or other apps. Some of the developers on the call would have used GitHub Copilot and other such. So these are the apps which are getting created essentially, right? So this is the AI stack. And then we are not going to go into all of this. We are going to go into specific things on how to use AI in your firm. But the AI landscape is buzzing, right? So you have the tech landscape, and then in each of these buckets, people are launching one after the other applications. I think all of us on the call know that. I'm just reiterating it. There are some which are slightly esoteric, like synthetic data generation, which data scientists typically work with. But I think this is going to become more and more common because there are models like Instruct GPT which have come. So creating a LLM model to create data for you, so that you can train your own models, like that has come up in the last 8 to 9 months. So that is something of note. And then we are getting into music generation. So we are getting into 3D video generation, all of those as well. Okay, so this is slightly important. When I started off, people only know GPT, but then when you start going deeper, you come across all the different models. So this is a snapshot from Hugging Face, which is like the GitHub of AI, where you can see you have text to image models, text to video models, depth estimation, image classification, a lot of natural language processing models. So if your worldview today is it's all about Mid-Journey and GPT, please go look at Hugging Face. You will realize there's a lot of research which is going on, and a lot of new models come out every day. Models like Mid-Journey and Open AI are prime examples where you take a model and then you make it user friendly, and then it becomes suddenly available to everyone. And but there's a lot of other models which might be more useful for you in your work. The other big trend which is happening is we are getting to larger and larger models. So people like companies like Meta, Google, and OpenAI, who have huge amounts of money, they have trained bigger and bigger models. VCs have funded them as well. Like Stable Diffusion is a good example of that. Stability AI raised $100 million of seed. Anthropic just raised $1 billion at $5 billion valuation for creating their own model. So what is happening here is essentially we are seeing there is this big debate whether the foundational models, the fundamental models, will be owned by these companies who can spend huge amounts of money to create the perfect infrastructure or the perfect advanced AI model. And there's obviously this other debate of open source. So not all of these models are available for research. So researchers have come up with their smaller models like Llama and Alpaca, essentially. And so there's this big debate which models will win. But today, my personal belief is firmly in the AI today is more and more in favor of larger models, because these larger models are demonstrating what is called emergent abilities. So emergent abilities like reasoning. So for example, you can give a model, 2 plus 2, and it might give you a wrong answer, but then you tell it, okay, let's do this step by step, and you will get a good answer out of it, right? Those things are happening when we go to larger models. The interesting bit though is these models are, people confuse sometimes because they give a sentient or artificial intelligence has arrived, but these models are really what I think as English teachers, right, with a little bit of logic. So these are very good English teachers. They know how to answer an English question you ask in English. They will answer you back in English, because they know how to predict English answers, right? And that is where the fallacy is. We need to disconnect ourselves from a lot of this, bias that I'm talking to a very, very smart person, right? So I think that is important. So please be aware of that. Yeah, but everything. So even though there's a lot of interesting stuff which is happening, not everything is ready, right? So, and this is a good example where we are in 2023, and we have gotten to a stage where of text, for example, where spam detection, translation, Q&A, copywriting, longer form of content, all of that has been solved, and now we have gotten to the stage where vertical fine tuning is happening, scientific papers are getting written. And then this will go on improving. But for example, for something like a video or 3D gaming, we are still at a very basic video and 3D models today. And the speed at which things are happening, hopefully we'll get to even better and better models in the future. So I think there is it's not, everything is not, improved yet. So that is the broad point, but it is improving at a very fast pace. Every week, we're getting like 10 to 20 interesting papers coming out, and which are getting converted into technologies for us to use. And this, I think, is something which I just wanted to highlight. There is a lot of issues which still need to get solved with LLMs in particular. LLM, by the way, is large language models. I'm sorry, I didn't talk about it earlier. So one is regulatory compliance for companies. Data privacy. I'm using ChatGPT, and is my customer information being used by ChatGPT or not? Is there data security or not? Or for example, let's say if you're a fintech company using ChatGPT, you come into regulatory compliance. If there is a bias in using their models, and that bias carries over to your decisioning, let's say risk decisioning, you could be in a soup, because you'll have to explain some of these things. Like today morning, somebody was telling me GPT has been banned, ChatGPT has been banned in Italy. I don't know for fact, but it's quite possible that people come up with that, or governments are trying to figure out how to regulate. I know US is thinking about how to regulate some of these things as well, right? They're coming from a very different perspective that world will get destroyed by AI, but I think the more real use cases is how much is data privacy, how much is data security in all of these models. Second is, like I discussed, more and more open source models are starting to happen. And the trend which is happening is you have industry specific LLMs. So people are wondering, should I use ChatGPT or should I use my own medical GPT or finance GPT or e-commerce GPT? So right now, all of us are trying to answer that question. And then there's reliability of AI. When you do any kind of coding, the language which we type in, like a Java or Python, if you write something wrong, you'll immediately know, because it will not either compile or it will throw an error at runtime. But the problem of using LLMs is it will silently fail. Even if you miss out some word, if you misplace something wrong, write something wrong, you will still get an answer. What you would not know is, did the answer change or not? Was there some error? So that you don't know. And all these models are probabilistic. So what ends up happening is that you give it a sentence, you are not sure that the next time you get the same answer, right? So obviously there's this concept of temperature or seed. You can get the same answer again, but it might also be the problem that you have to be very careful of using some of these randomness. Fourth is this bias of LLMs, right? So large language, we will talk about this in the presentation. What is a database on data on which all these LLMs are trained, right? So most of these LLMs are trained on scraped data, which is primarily English, and the US and the the US and European Union are the biggest producers of such content and so obviously there's a lot of bias around that data, right? So today, if you go and try to create like a uh, image of an Indian man, you will typically find very dark tan villager. That's what gets created in most of these models, right? And that's the kind of bias I'm talking about. And then finally, we have all of this LLM things which are available, but how does it translate to our application development? A lot of new skills will have to be learned. Prompt engineering is coming up as a new career in the US, and it's debatable whether that's a good career or a bad career. If LLM models become even stronger and better, that they will write the prompt themselves, or the requirement for prompt engineering will come down. But so even though we are excited about the whole space, or even though I'm excited about the whole space, there is a lot of challenges which need to get solved. But the great part is a lot of innovation is happening right now that hopefully all of these will get solved in the next few months or quarters, and we'll get to a much more sophisticated form of AI, which we can use. It will be much better. The version 2, version 3, version 4, maybe GPT-10 might be even much better, right? So that's the kind of, but it's going to happen very fast. So coming to LLMs, so this is, I've tried to make the presentation such that we have folks which are novice as well as folks which are, slightly advanced. So we'll cover slightly, this is the slightly, entry into learning about AI kind of for the next 10 slides kind of speed. By the way, I request my Axel team to let me know if I'm going too fast, because unfortunately, Zoom is not very good for feedback. So you guys can WhatsApp me and let me know. So on LLMs, what does the LLM do? LLM is a large language model. It essentially takes a text input and it gives you a text output by processing that input as essentially an input. And it also provides you a numeric representation, which you can use somewhere else. So that's essentially an embedding which you can take that and put it into vector databases. It allows you to do semantic search and chaining and a bunch of other things, right? So this is what an LLM does, right? So, and this, what is this LLM used for? So this LLM essentially has 5 major use cases, which are these big boxes in the middle. So one is write. So you make an LLM write. Then you can make the LLM rewrite. You can chat with the LLM. So Q&A kind of LLMs have to be trained separately. Then you have summarization of a text, and you can extract questions. So you can extract information from it. You can extract answers from it. You can extract things like, okay, which is this person talking about, places. So this is the fundamental which all LLMs work on. The way to then you direct these LLMs or program these LLMs when you give input instructions. So you have expand. Okay, you wrote some. Let's say I ask, what is Bengaluru? I'll get some answer, and then you can say expand on your answer and it'll add more details about it. Or I can say rephrase your answer so that it can be rephrase your answer so that it's part of a novel, and then it'll change it stylistically. Similarly, condense so that, or summarize it, or I give it a text and say identify all the people that are being talked about in this particular text. I'm sure I'm not going to too much detail because all of you would have tried around and played around with GPT. Seems like from the, if you have not, GPT is free. This is not the forum for that. Please spend your time playing around with it. It's a very intuitive tool to use. But this is fundamentally at the most fundamental level. These are the 5 things LLMs do, right? And then we can obviously build on top of this by adding other things like search. Classification is another one such example. Classification allows you to say, okay, what is this? Like if you have given 5 or 6 different multiple text pieces, and you want to classify them into, let's say, horror, comedy, things like that. That's what LLMs can also do for you. This is just an example of explaining some of the use cases. So I'll explain this diagram for you. So T0 is a LLM model. On the left, what has been given is a text, this summarization text. the picture appeared on the wall of a Poundland store on Weimar Avenue. And it goes on for some more words. And at the end, you have an instruction to the LLM model. How would you rephrase that in a few words, which is summarization, right? And then you get an answer from this, which is graffiti artist Banksy is believed to be behind. So it gives you a smaller answer. That is summarization. So let's say I give you 1,000-word text and it condenses it to, let's say, 100 words. Sentiment analysis. Sentiment analysis example is there's a review, let's say a movie review or a restaurant review. We came here on a Saturday night and luckily it wasn't as packed as I thought it would be. So customer goes on and says some things, and then we have to program it to say, okay, on a scale of 1 to 5, let's say 5 being positive, where should I class sentiment? What is the sentiment of this customer? So the language model can come out and give me a number for that, right? Now, how is it doing it? I mean, that's a science. Most language models behave like a black box. Nobody knows, but you get an answer from it, right? So, and then question answering. This is where ChatGPT essentially is, which is I know that answer to. I want to know the answer to. I know the answer to what team did the Panthers defeat. Is in the Panthers finished the regular season in this sentence. Can you tell me what it is? Right. So it picks out. So it's analyzing a text and it's understanding that you are telling it that I know the question has the answer. What team did the Panthers defeat? This is the question. Its answer lies inside this text. The Panthers finished the regular season. Can you tell me what it is? So it's able to understand that you're asking it a question for finding the answer within a particular text, and it tells you the answer. So this is an example of question answering. When we ask a question directly to, let's say, open ChatGPT, what is Bengaluru? It has scrolled through, it has basically scraped through a bunch of questions on Wikipedia and others. Please understand, it does not maintain that database. What it knows is if somebody asks this question and I have to answer something around explaining Bengaluru, then it finds words and predicts those words which will form a good answer to you, right? So that's what it is doing. I think that's one of the key things which I want to explain. Maybe just let me hold on. And by the way, guys, please feel free to send in questions. Let me see if I can show you one. I'm sure people would have already experienced this, but okay. So let me ask, this is ChatGPT. Let me ask, what is Bangalore, right? And it will give me an answer. Bangalore, it's all great. But I can, the amazing thing is, okay, it's still going on. Wow. Right. So the great part about this is, let me ask this question again. What is Bengaluru? And I can tell it to be concise, right? So it'll give me a short answer. Right? Very crisp, very short answer. And then now I can say, this is where things become interesting. So I can say, you are wrong. Bangalore is a fish. So here in this particular case, very interesting that ChatGPT is very confident about its answers, is arguing with me. Okay, but let's say I'm sure that Bangalore is not a hub for IT, but for toy industry. So it's very sure of its answers because it has a lot of confidence in the answers which is given. But let me ask this question, okay, who is Priyank Sarup from Axel, right? Right, so now what it's saying is it does not have information, but see what it's saying. It's saying Priyank Sarup is associated with Axel, then he must be a venture capitalist or a employee of Axel venture capital firm, right? And this is where semantic search comes. It basically knows Axel, you're saying it's Axel, it knows it's a venture firm, and then venture firm, it doesn't know exactly who I am. So it knows that either I must be a venture capitalist or an employee, right? So this is part of semantic search. which unfortunately is not a topic we are discussing today, but it tells you some things about the abilities. And it's very funny. You can go in, start discussing this, and you can sometimes people who are already well known, or maybe I'll just show you one more example. Sorry on this. So who is Shekhar? Shekhar is one of our more popular partners. Right. So in this case, it's mentioning Shekhar Kirini is a partner at Axel, and it's a nice answer. It's a correct answer. But here, let me try confusing. Wrong. I say Shekhar Kirini is an analyst. So let's see what it does. So I've given it some input saying this is wrong. Oh, wow. Okay. Something has happened. Because till yesterday, it was saying, okay, I accept that Shekhar is an analyst at Axel. Interesting. So, I mean, this tells you that models are also evolving, or though I don't know why, but let's see. We have tried too many times that Shekhar is. So now this brings me to the other part very quickly. Not all LLMs are made equal. What I mean by this is there are 2-3 parts. So one, as a user of LLMs, you have commercially using LLMs, you need to know a few things. So so ChatGPT 4 model is closed, training data is not disclosed, so you don't know what it has been trained on. Like for example, it knew who Shekhar is, but not me. Model weights are unknown, checkpoints are unknown. We don't know whether it is optimally compute trained. We don't know the license exactly. Right? Our license can changes. It can change. We'll compare that with, let's say, a Pythia, where the model architecture is known, training data is known, model weights are known, checkpoints are known, and then it's an Apache 2 license. So we can use it to do a bunch of things. So this is one set of, when you are deciding which LLM to use, these things also come into picture. The other big piece which people, when you start off with AI or LLMs, is don't know is not everything is the same color, right? Which is, there are all those 5-6 use cases which I showed to you. Not every model is very good at everything, right? So for example, GPT-3, which you see here, the third row, it was very good at conversational AI and content generation. But for example, it was not as good in text classification or information extraction as BERT, right? So when you are solving for something in your company, you have to be aware of which model to use for. I think that is important, right? So just so you know, and there are a whole lot of these, and as we talk, you will realize that GPT, for example, GPT-4 is expensive, so you might want to do things like, okay, for my AI journey, I might use one particular model first, and then go on to use something else. So you can do a chaining of sorts, or a step-by-step. So first step, I will use BERT, then I'll use GPT, and then maybe in the next step, I'll use Palm. You could do that as well, right? Essentially, because inputs are text and outputs are text. So, okay. Sorry, I'm rushing through all of this. Slight detour, which is, I was just very curious as to what data our LLMs are trained on, right? So if you were to figure out how does GPT-4 answer all these questions, how do other LLMs answer questions? So this is an example. So Bloomberg came out with Bloomberg GPT, and they basically showcase very nicely in a concise fashion that what data set they have trained their LLM on. So they have trained their model on 708 billion tokens. And if you look, they have 2 parts. So they have a financial data set. Okay, there is a question. 1 second. Yes, Sarfraz, please. Sarfraz, you have a question? Sir, yeah, sorry.
Yeah, we are still stuck on the ChatGPT screen. We are not able to see. I think you're showing something else, but on the ChatGPT.
Thank you. Thank you. Yeah, let me see this. Okay, can you guys see my screen now? You can just type it in the. Sneha, can you see my screen? Sneha Prachi?
We can, PS.
Okay, thank you. Okay, so my bad. Sorry, I went through a bunch of things. So not all LLMs are made equal. That's what I was showing. And as you can see that there are multiple LLMs in the market. So you have model architecture, training data, model weights. A lot of these things are either published or not published. And when your company is using one of these, you want to know what you're using, right? How much is known or not known, right? So if you're using a black box, when the black box changes, then you start getting some different answers, all the work you've done. So this is one of the more critical elements. This is why there's a lot of debate happening on open versus closed source GPT models. Though I should definitely say that GPT-4 has an exceptional performance right now for most tasks. So it makes our life harder, when you're choosing something. Okay. Prachi, meanwhile, can you check how do we enable chat for everybody? I'm still not able to figure that out. Oh, actually I can. Folks, I've enabled chat.
Yeah.
I've enabled chat for everybody. And guys, I've enabled chat, so you can type on chat if you want and talk to other folks also. Please try it. Essentially, right? So it's enabled now. It was my mistake. I couldn't figure it out earlier. The other slide which I was showing was there are a lot of models of LLMs, and as you can see, there is different use cases, different things are good for. So I was taking example of GPT-3 here, which is the third line. It is very good in conversational AI. It is very good in content generation, but it's not so good in information extraction and text classification, for which you can use BERT. And you could also make a chain where output of BERT goes into GPT, and then the GPT output goes into yet another model, let's say like a PaLM. So that is also possible to do. And people have done that, and it's one way to optimize for cost and optimize for performance, though it obviously is time consuming, right? So most startups today, when we talk to them, are just using GPT APIs, and that's a good place to start. But as you think about optimizing costs and optimizing performance, then you might want to think about multiple LLM chaining also, right? So next is slide detour. So slide detour is basically, I was just curious what all data LLMs are trained on. So this is example of Bloomberg GPT. 708 billion tokens the GPT was trained on. And if you look, they have two sets. So they have a public data set, which is at the bottom, which is roughly 49% of their data, which is publicly available data sets like Wikipedia, C4 and Pile. Like C4 and Pile are available for download for anybody who's researching, if these are open source by other researchers. And then they also did proprietary data set. So they basically had like 54% of their data set was proprietary. So they went and scraped web, they went and scraped news items, filings, press reports, and then their own proprietary Bloomberg data. The reason I'm saying web, news, filings, and press are proprietary because they ran their own scrapers to get that data, clean that data, and do all of that. And Bloomberg, for those of you who don't know, provides financial data. It's like Traction, but for a lot of global companies, public markets companies. So they had their own data sets as well. So they combined all of this into, which became like a 708 billion tokens. So roughly a token is like 1.4 words or 1.2 words. So they used all of this to train their models. So similarly, any company can use public data sets and can have their own other data sets to train something. What do you get out of it? So they got slightly better answers for questions they were looking to answer. So that is why you would want to do it, and we will discuss it again in fine-tuning section. This is the Pile. So if I go back at this 2.2.1, the Pile, this is a very large data set which is available for anybody to train their models. This is what is inside the Pile, and I think this is important for people to understand, right? So you look at this. So you have books, 100 GB of books, which could be Gutenberg project. Archive is the scientific papers which are out there. GitHub code. So GitHub has open source some of its publicly available data, or open source. People allow derivative works. So that is what GitHub data is about. So that's why a lot of these language models are able to spit out Python code and other possible code. And then you have subtitles, open subtitles, the very interesting data set. Some like a decade back or so, when we were in college, Netflix was not popular in India. People would download things from torrent and then add a subtitle file, .srt file, so that they could read the subtitles. So all of that was crowdsourced. So that data set is, what is that data set? That data set is essentially one actor talking to another actor. And it's essentially a conversational way of, if somebody asks a question, how do you respond? Right? So that data set has been used. And it goes on, right? So you have Hacker News, long form content, all of those things are available. Essentially, this is inside the pile. It's a good collection if you want to play around with it, right? So this is just, and then this is the other look, right? So not like Bloomberg GPT was trained on 55% proprietary database and 45% outside. Similarly, you see here that different LLMs have various ratios of data inside them, and that's why the text they generate is very different, right? So for example, Llama, which was made popular by Meta last month, essentially had 87% web pages, right? And very little conversational data set. So I would assume that it would not work as well as something which was trained more on conversational data, let's say like a Lambda, right? So that's the kind of, you need to understand a little bit when you start going into nitty-gritties. I think this is slightly on the advanced side, but you still need to know what you're using, right? So this 101 on that. In summary, it's a wild west of LLMs out there, lots and lots of LLMs, and you have to figure out what it works for. That's all the key takeaway from this section I wanted to main. And GPT is not the only one, but yes, it's the easiest one to get started with. And then I'll circulate this deck. So there are some resources if you want. By the way, training LLM from scratch is very hard. It's very expensive, but it's good to know. All right. Now comes the fun part. The fun part is Stable Diffusion demo. I'm doing this because a lot of folks have marked that they haven't used image generation, or so this is an image which was generated by me on my laptop. So I run Stable Diffusion on my laptop. I have a 16 GB RAM Mac, M1 Mac, works nicely on it. And I'm going to just show a quick demo. So this is one image. This is another image from another model. And then these are 2 3D images, which are again created on my laptop using the Stable Diffusion model. So I have Stable Diffusion running here on my laptop, and there are a bunch of checkpoints which I have with me. What it does is Stable Diffusion essentially it does is I can give it a text. So this is the text. I write something here, and I tell it to generate, and it will create that image for me. I get that image generated here. What you're seeing, some of the other parameters are like width and height. So, I can make it. So most models today work on 5.2, and unfortunately for me, higher than that is troublesome to create. So let me just. So what I'm trying to create is a steampunk horse head. I'll make it slightly easier to read. So, okay, let's give it this is a simple prompt. So steampunk horse head, high contrast, micro details, octane render, photorealism. I want it to be a realistic photograph. Let me reduce the. So this will just come. This is computational steps. So, we will probably do a session just on image generation later on. But for today, so I've given it some steps, width and height. You have to choose a sampling method. I'm not going to details of that. And then you just give it, and it's going to start creating an image on my laptop. And you can see as how the image starts getting created. So I'll just wait for it to finish off. Right. So horse head image, I'm not sure whether this is steampunk or not, but it has been created. And similarly, you can go on to create a lot of different artwork. So let me show you guys. This is one website. Okay, looks like this one is down. Interesting. Civit AI is one of the websites where you can go and download a lot of prompts for this, but I'll do one more thing. So say, and small boy playing with, playing with ball. Let's see, high contrast, and we'll just keep it very simple. And then let's just generate once again, right? And you will get image. And the interesting thing is every time you run this, you'll get a different image because that's the way we will talk about diffusion models at one of the webinars later on. Yeah, so you can see start generating. Meanwhile, looks like this website is up. So this website is basically a collection of different images which people have generated using using different stable diffusion models. And the great part of this is you can see how this image is like, we are just limited by our own creativity. Now you can tell it stuff, it will do stuff for you, but you need to know what to tell it, right? So for example, if I want to know how this image was created of this cat, which has some metallic armor, I just need to click on it and I'll get this prompt, right? Cute kitten made out of metal, cyborg, blah, blah. And it has some negative prompts. A negative prompt is used when, because it's AI, it's creating and drawing. Sometimes you get extra limbs, extra hands, extra fingers, or disfigured. So you have to give it some negative prompts. Don't do this kind of thing. And it's as easy as I can just do copy generation data. So I copy all of this. I come back here. It's you can see that it's creating that photo which I requested it to create. So I'll let it finish. And then you can see it created a photo of that. And then this is not looking realistic, but we can play around with the prompts and do this. Again, I'm just making smaller sizes so that works out faster on my laptop. And let me do this, right? So it will create image of a cat. Meanwhile, we can explore here. So you have a lot of models which you can play around with. This website is working very slow. Yeah. So for example, if you want to draw manga characters, you can use the prompts here. I think somebody in our portfolio was trying to create, hand-drawn images. So you have a lot of, let's say you want to replicate some of these. Oops. Okay, I just realized because I was running this on my laptop, my video might have been choppy. I'll just shut this down. But I think you get the broad picture of how we can use stable diffusion. So that's what I wanted. Any questions till now on any of this before we go to the next part of LLM ops? Any questions from anyone? Okay. All right. So then I'll move to LLM ops, and I think I've been talking for too long. So maybe we'll not go deep into this one. We'll quickly cover because I want to cover fine tuning. So what is LLM ops? LLM ops is, okay, there's some question, which is, all right. Yeah, that's straightforward. Yeah, it's a very straightforward process. So, okay, to install LLM Stable Diffusion on your laptop is a straightforward process, but be aware you need to have very good GPU as well as RAM on your machine. Now, okay, we are going to talk about LLM Ops. What is LLM Ops? LLM Ops is all about using language models, large language models inside to create applications. And so we are going to talk about this piece from this diagram. Yes, I'll be sharing the presentation. Yes, Kritika has asked, can we upload an image to Stable Diffusion and ask it to edit it? Yes, it is possible. There's a process called in-painting and out-painting. In-painting is you have an image and you can tell it to change certain things. Out-painting is you have a small image and you want to increase the size of the image, and it allows you to do that. So LLM Ops is fundamentally 5 things. First one is prompt engineering and management. Second one is data and embedding management. Third is fine tuning. We are having a session on that. Then you have foundational programming frameworks. And then once you have done all the programming and you want to know how things are going on, you have, like your DevOps, you have deploy, optimize, and monitor, essentially. Right. So these are the 5 buckets. Today, I think I have data on 2 or 3 of them. I'm not, but it's a very, very, what do you call, rich ecosystem now, even though things are starting and things are coming out, daily things are coming out. So let's just do that. Okay, we answered this question. Sorry. Yeah. So things are coming out regularly. Now, before I get into prompt management, so I'm going to cover each of these. So before I get into prompt engineering and management, I showed you some examples of how I was using ChatGPT. Essentially, every prompt is consistent of, three parts and then a refinement. So 3 parts is like context. So you are, you have to give it a context, right? So you are an expert nutritionist, right? So you are a nutritionist. The moment you add expert, you become expert nutritionist. You want to give instructions. So for example, to the GPT saying, I want you to provide an answer in bullet points. I want it to be concise, like I mentioned to you, like I showed you, right? Or you want to give it a task, and then it gives you an output, right? So for example, here, the context is you are an expert nutritionist. I want you to give me an answer in bullet points, and I wanted to create a meal plan for 2000 calories a day, right? All of us struggle with this level, so this is the way you will get a smart answer. And then what you do is you can refine the answer. So you can say, replace meat with fish, or I am vegetarian, please change, right? So this is how you can get, this is a prompt design, right? So you have to design each part of it. What is the context should I give? What is the instruction I wanted to give? What is the task I wanted to achieve? And then once I get an answer, I have to refine it. So when you refine it, then you are creating a new prompt, right? So this is all about that. And then as you start using this inside your organization, there are 2 things you might want to be aware of. So one is like a template. So people have already done so much of prompts, right? Why recreate everything by yourself? So there are places like places where you can go and just find other prompts, right? So sorry, let me see. Actually, the best answer will probably be prompt based. So for example, the images I showed you, right? So Civit AI was one prompt template, but here, for example, you want to see how do I create something like this on Mid-Journey, watercolor object paintings. You want to create this. So what you can do is you can buy this prompt. Somebody has spent time and energy and effort in figuring out how to exactly create this image. You can buy this prompt for $3. It will save you some time, right? So I find these places quite nice, where you can just go and see all sorts of prompts available in the marketplace and see what can be done. That's first, and you can buy them all, of course, but I would recommend you can do GPT, right? So for example, you want to give it an idea and create a book out of it, right? So here's so look, the way to look at this is this is a prompt for GPT 3.5 turbo to be precise, which is a model. And the example input is, write me a book on motivation versus discipline. And the prompt guy, the person written the prompt, has started showing the first few paragraphs of the response on motivation versus discipline. Now, this looks like a very simple prompt, but inside it, he would have given more prompts, right? So this is a simple way to get you started on a bunch of things. like for example, stable diffusion, which I was demoing to you. If you want to create different images, how to create that image. You could look at these images and say, okay, let me figure this out, right? And you can buy those again, just to kickstart. Very cheap way to get started and experiment. But yeah, so this is one example. So this is a prompt marketplace. Similarly, you have prompt templates where ready-to-made templates are available, and you can just start using those as well. Second is prompt management. So prompt management is essentially like, we were trying and experimenting with the prompt. So think of it almost like you have to keep let me see. So maybe I'll show you a demo of this.
Welcome to Prompt Lab with Open Code. The only thing you have to change is instead of importing OpenAI.
So I'll just voice over what he's showing. So as you experiment with prompts, you can see here, like this is, you can manage projects. So you can say, I'm creating a name guessing prompt, and this is my second pipeline, and I'm experimenting everything on top of this particular model. And this is the number of tokens I give. So if I give this prompt, this is the response I get. And then you can play on with this, and you can see, so this is a tool which allows you to see response of the API input and output. Then it allows you to share this with your friends. So, or share with this within your organization, and also manage, different projects. You can favorite some things. So this becomes important as more and more people in the organization start using, using prompts. And then you can have templates, right? So you want to have, okay, you see if. So for example, this is a template. So my name is, and this becomes an input. So you are creating a new prompt template where you have my name is, and I live in, so, and then you can save this template, right? So, and then so that you can reuse it again. So this is an example of a prompt management software, fundamentally, right? So I'm just going very fast. Then you have data embeddings and management. This is semantic search. So when we search on Google today and you search for, let's say, Priyank, so my name, Google is essentially going and trying to find all those texts, all those web pages where have that text which is available. But with AI model, with LLMs, we can do semantic search. So semantic search, the easiest way to explain it is, let's say some of us have used Google search on images. So how does Google figure out that this person is using for a black shoe, right? The simplest answer earlier was Google will look at the image, try to understand from image to text, it will convert it into black shoe. Then it will go and find the same mapping across all its database, and then return you all those. Works nicely, but sometimes it's not perfect, right? Or not great, because the concept of black shoe is different. So semantic search is run on top of vector databases. Pinecone is an open source database, and Viviate is I think Viviate is also open source. Also, there is Quadrant, there is Chroma, which we will discuss. And these essentially allow you to add memory into your database so that you know that the answer which is coming is based on the data which you have provided. It's not coming from some random unknown place, essentially. And how does that work is something like this. So you take a set of documents, you break them into chunks, and then pass them to a vector database. This vector store is essentially a vector database, and it's called embeddings. We are not going into what embeddings are, but essentially it's like a matrix with numbers in it to represent each input. And then what you do is when you ask a question to an LLM, you also tell it that, hey, look for this answer within these documents. So you pass this question to a vector database. Vector database will give you a set of documents, and then you can pass that document to the LLM and say, find me an answer from these documents. So that's how you pass context. That's how you, actually not context, that's how you pass the data to an LLM to find an answer which is within a bounded space, within something which you know that you control, right? So if you are, let's say, creating a use case for, let's say, support, and your support agent needs to find an answer for a question asked by the customer, you don't want to go and query ChatGPT to find an answer. You don't know where he will answer from. where GPT will answer from. So you want to go and look at, let's say, all the FAQs, all the training manuals, everything else where the answer lies. So this is the way to do that, right? This is the way you will pass all your training manuals, FAQs into the vector store, and then create an agent for the create a AI agent for the support agent and answer questions from there. And people have done that. Some of our companies are using this to answer L1 questions, essentially, right? Where they know that this is simple. So customers is not talking to a human agent, but actually talking to a agent which is programmatic. The third part is, giving context. So when we use Chat GPT maintains context. When I said, who is Priyank Swaroop, when I said you are wrong, it knew that when I say you are wrong, which question I'm referring to. But when you create your own applications, that context gets lost, because essentially whenever you send a question to LLM, you're giving it a question and you're getting an answer back. So that's chat history. It has to be maintained somewhere, right? So you have to provide the context to the LLM. And this is where it starts becoming important to add memory to all your conversations. This has to be maintained by you when you are doing your programming. So what this diagram is showing is this. You have been asking a bunch of questions to the LLM. Now you ask a new question, right? This chat history has to be maintained and passed to the LLM to get a new question. This is the context. And then you can tell it to go look inside the vector store to get the answer. So this is a very simple concept, but this is important, that when you're using these APIs, you have to maintain the context and give it the context. That this is the memory you have to create, right? And then to enable all of this programming, a lot of programming frameworks have come up about. The most popular one of them is LangChain. It supports a large number of LLMs, supports a large number of vector databases. It has raised a bunch of venture capital money, and it is becoming a hot buzzword. Very good documentation. I would recommend you to go and have a look at it. And essentially, LangChain's chain comes from the simple fact that every question you ask an LLM, the answer can be chained to another to perform some task. So you can create a chain to perform a task. That's where LangChain comes from. So it provides. So LangChain helps you making your company app be data aware by connecting it to vector databases, be agentic, so almost like an agent, and be LLM agnostic. So today you can use at one step you are using AI, and the other one you're using something else. And then these are the different kind of things that LangChain provides. So on the left, you can see a schema, models, prompt management, indexes, memory, chains, agents. We are not going to go into deep into all of this, but just to tell you overview. And then it allows you to build very fast personal assistants, question answering over docs, chatbots, and the like. You get the gist of it. So it's a good framework. I would recommend you to spend some time on it. Play with GPT, understand. Just take one LLM first, GPT, work with it, understand the APIs a little better, then then start using LangChain. While using LangChain, you learn all the other concepts, is my recommended path, basically. All right. Any questions till now on this? Sorry, I went on a very long monologue. We can answer a few questions, and if Jacob and Naveen are also here, I'll just promote them to panelists so that they can also come on stage. So Jacob, you're on stage, and Naveen.
Hi, Priyank.
Hey, Jacob. Hi. Hey, Naveen. Hi.
Hey, Priyank.
All right. So Jacob, Naveen, thanks for joining us. I'll set the context a little bit. Maybe actually let's flash the slides, and I'll flash the slides just so I'll introduce you guys, and then So, Jacob is VP Data Science at CleverTap. For those of you who might have tracked, Jacob has been doing it for a very long time. And at CleverTap, they recently launched a product which was built on AI. Jacob, maybe you can talk a little bit about it, set the context.
Sure. You want me to talk now or after you introduce me?
Maybe actually let me finish Naveen's introduction and then
Yeah.
we will come back to each of your products. So Naveen, the principal product engineer at O/Slash. He has worked extensively with Elasticsearch, amazing skills, and understands search very well, semantic search very well. And he has been also fine-tuning LLMs as well. So, thank you, Naveen and Jacob, for joining us. And the next 30 odd minutes we will try to go through this discussion on fine-tuning. So maybe Jacob, Naveen, Jacob, you first. Can you talk a little bit about what the product, about yourself as well as the product which you guys have built at CleverTap?
Sure. So hi guys, I lead data science at CleverTap. CleverTap is a leading user retention platform. Basically, we power around 24 billion notifications on a daily basis, reach around 5 billion users monthly. Talking about myself, basically, I was an investment banker. I've done about a decade of investment banking, shifted to data science around a decade back. And I've been with CleverTap for almost 8 years now. In CleverTap, basically, we have some few features which are powered by machine learning, ranging from automated segmentation to recommendations, and a few other features. But the latest one in the sense is we have developed a way to extract emotions from text and serve and generate different copies of the text. Why this is important? Generally, in the life of a marketer, there are 4 things which are important. First is basically based on whatever KPI that you have. Maybe you want to reduce uninstalls, maybe you want to increase transactions, various some of these KPIs they would first look at who the users they want to target, which are the users they want to target. Then they would say, okay, when you want to target, where you want to target, right? Which means channel you want to target, right? Whether it be email, SMS, in-app, push notifications, various other, or web or whatever, right? And then ultimately is what section, right? Which is what copy you need to send. That copy may be this could be the actual text, the images, the recommendations and stuff like that. So what is a very key portion of the entire game. And a lot of times what we have observed is people tend to falter on the what section. For example, they send repeated messages, or they send messages in the tone which is not in consistence with the brand image. There are research which states that 52% there are customers who are 52% more valuable if they are emotionally connected rather than just satisfied customers. So emotions becomes a very key part of the game. And then obviously, how many messages can you create, right? I mean, there is always a writer's block in mind. How do you write those messages taking into account a specific emotion? For example, I want to increase FOMO, or my messages need to have more joy, or I have to create some anticipation in my message. So those things becomes very challenging. You have to the 2 parts of your brains have to, left and the right, both have to come in, jointly and work together. The analytical part and the creative part, right? So that's a challenge. And this is where we introduced a feature wherein, based on what emotion you want, right, you can come out with various variants of a specific text, very campaign creative. Or maybe you have a campaign creative, right? So for example, 50% off on shoes, offer ends tonight. Now this statement itself, because it is offer is ending tonight, it tends to create a FOMO in the sense, right? Now, maybe your audience is not too much into the FOMO game. They maybe want to have more of joy. So instead of 50% off on shoes, maybe you're saying, hooray, you won 50% off of use coupon, till before it expires. So these kind of, variant stuff, it's very difficult for, to do this in real time or quickly enough. This is where this feature comes in, to basically help marketers paraphrase stuff, create campaigns, analyze emotions. So this is where we have used a couple of LLMs, BERT for the emotions part, and GPT for generating the text side, the various variants of a specific campaign.
So Jacob, just to summarize what you said, I mean, you're using BERT for, you said emotions, and
Yes.
then GPT creating the messages. So BERT helps you understand the emotion, and then
Correct.
you take that output and put it into GPT to create messages. And then these are automated, or the people have to approve those messages?
No, we will, never have the automation directly, right? Because we'll give the control of, sending that out to the marketers themselves. We won't do it automation. That brings a lot of risks, right, associated with it.
Right. Fair enough. Okay. Maybe let's just finish. So what were the actually, let's shift to Naveen. Sorry, and then we'll probably have a tango between the two of you. So Naveen, if you could talk about yourself and what you are doing at O/, and how you've used LLMs, that'll be great.
Hi, Brink. Can you hear me?
Yeah.
Cool. So I'm a search engineer. I have been there for 12, 13 years in search. I started with Lucene and it moved to Elasticsearch, and now we are currently in semantic search, right? So the evolution has happened a lot on search. The semantic search has bring a new direction or dimensions to it. We can basically ask any questions. Previously, it will be a direct match of two keywords. Let's say you have a Elasticsearch will match with a, or any other search engine that will directly match. But here you have to generate vectors and you can find the nearest matching vector. So you'll always find some results. It's not like you'll always find a result. Then it is your, you can decide you have to show it to the user based on the distance or not, right? So what we do at O/ is we have a lot of integrations like Notion, Gmail, Google, all those integration. We usually give search on top of it, right? So for semantic search, when GPT came out, we started investigating more and we started implementing it. So the more challenging part was generating the embeddings and storing it and making it conversational. So that's where we are currently doing all those GPT-5 or Flang T5 for Google to generate the embedding, storing it, and searching it. Right. Mostly we are on the search space where we use more on the semantic search and the conversational AI part of it. You're on mute, Frank.
Sorry, a lot of the audience might not know about semantic search and embeddings. So, is there a simpler way to, help people understand that?
So, okay. So basically semantic search is a vector database. You can store all the vectors. Okay. When I said Elasticsearch, right, it basically stores data in a keyword format. Let's say I am a boy, it will store it in a keyword saying that and it has a frequency to associated with it, am and the boy. So it stores in the invert index. And when you query it, it actually matches. It's like an matches the same exact words and do it, right? But when you store it in a vector database or a vector database, you basically use a model and generate embeddings and then store it in the vector database. Like it will be like a vector, like mathematical vector. It's not in a keyword format, right? And when you make a query on there, you can also, you have to convert the query into a embeddings or a vector and then match it with the nearest distance. I think that's where you were explaining in the before slides, where they convert it and match it, right? So even vector database stores the database in an invert index, but it stores in a vector than a keyword. So it can basically match it. There are algorithms like cosine or KNN to match the exact vectors, nearest match, and then it's how the semantic search works.
So I think something like if I would like to draw an analogy, it is something like, if you have played cricket, right? You can still take a shot at baseball.
That's kind of true, yeah.
Interesting.
But it's it's not very it's not both are not same, but it's a similar thing.
Yeah.
So Naveen, like one simplification of your use case is people here can use O/ for searching through their entire Notion document, and your search is better than, let's say, Notion's. To achieve that, you're using vector search, and the LLMs you're using are Flan and T5, right?
Yeah. We are
okay.
also using GPT to compare which one is better. We're currently in that phase to fine tune. So there are a lot of privacy concerns. We don't want to rely only on GPT at this point because it's became closed source. As you said, we are not exactly sure what's going to happen next. So we also wanted to train our own models and see if we can match it with, I mean, not like fine tune T5 or something, and see if we can match approximately 80 or 90%, then we can use our own model than GPT to make it work.
So just give me one, I just want, so by the way, guys, we are discussing fine tuning, but today you can't fine tune GPT-4. And Jacob and Naveen, correct me if I'm wrong, this as a week back, I picked it up from the website. So.
Yes.
Yeah.
Yeah. So I think they'll introduce something on the fine tuning aspect that is expected, but it will take some time. But at least for the 3.5 and all, you can still fine tune.
Yeah. But the performance between 3.5 and 4 is so vastly different.
Correct.
But yeah, I think it's at least for people to start, just like instead of trying out too many different what I call LLMs, at least 3.5 gives you a consistent framework and APIs, as well as a lot is written about how to fine tune it, that people can use it probably. So so we will like have some structure to this conversation. We discussed like, Jacob was talking about emotions and then generating content from those emotions was a use case they were working on. Naveen is working on, let's say, vector search to help improve search within O/, right? Now, the questions to both of you is like, you guys decided to fine tune versus training a new model. So help understand why did you do that? So, maybe Jacob will go with you first.
Yeah. So frankly, this emotion detector tool that we had developed, that was developed 2-3 years back, and we've already released that.
Okay.
But at that point of time, we didn't have the capability to generate, X number of new variants based on campaign text based on a certain emotion, because that tech was not available, which GPT solves for that. But even if you take emotions, right? If I put a prompt that give me identify the emotions in the text, I'll give some 5 emotions, and I'll tell that GPT, please give me. It gives me wrong results. Extreme. For example, I give you an example, right? 50% off on shoes, offer expires tonight or valid till today. Now, I don't need a mathematical model to tell me that FOMO is the highest, should be very high for this kind of text. But GPT fails, it gives me like 30%, 40% or 100%. Whereas our models gives, in the range of 80%, 90%, stuff like that. So that itself, it is, and we've tried various iterations, right? And that was kind of a that was kind of a, an evaluation test for us also, like whether our model is still holding yeah, in the face of GPT and whatever we have tried in the past, whether it was working. So that is because you need to understand what is the aim of the model, what in what data set it was created on, what are the problems it is trying to solve, right? It is not, if the problem it is trying to solve is not purpose built to solve the problem in your specific domain, you need to fine tune it. Right? So if I take, for example, the same analogy that I used in terms of baseball and cricket, okay, the model is able to play cricket, right? So at least it knows how to hit the ball with the bat. Now, can I fine tune it to get it to play baseball, right? Give it certain rules, give it certain more, insights into how a baseball, what is the angle, the trajectory, the ball is coming at usually compared to, a cricket. And then, it can understand, because basically it has understand the rules of, hitting the ball based on certain angles. You know? So first need to decide, whether what is it that you want to achieve.
Got it. Naveen, for you guys, like you are doing search, which is very interesting. Like,
Yeah. We wanted to try out our new models. And when we decided to go with the new models, we have to the compute cost and other things were so high. We don't want to spend a lot of time there to start with. So we saw, okay, fine-tuning a model will be to start with, that will be the easier path. As you said, anyway, most of the people, somewhere we have to start, right? So when we started the fine-tuning, so the custom data part is the most complicated part we have. We have to get all the data, we have to clean it, we have to also add generate embeddings. Even for generating embeddings, you have to have a LLM model, or you have to do it, right? So at the time we created fine-tuning models for any number of each customer will have a fine-tuned model, right? So basically that's where we got more complicated, because even let's say I have a Notion document and you have a Notion document, I cannot share those documents, right? So if I train it with the same model, the data may leak, right? So I don't want that. So we have to separate all those scenarios, and then we have to
Naveen,
generate
are you saying that for in your case, which seems to be different from Jacob's case, for each customer has their own fine-tuned model?
Yes, that's how we can train. Because let's say, yeah, personalization, and when you go that level of personalization is when you can have good conversational, as well as the data, the accuracy of the data will be very high, right?
Oh, that's very interesting.
So actually, just to add, I mean, we are treating these as special class, or something very different, where you have to have a fine tuning for every customer. But this is something we are doing for so long, right? If you take any recommendation systems or predictive systems, it is always built on a specific client data set. So this is not a sea change for us. We have been doing it since so long.
Yeah. That's true. But so what happens is when people think about GPT, right? So it's a single model that can do everything. So when the people mindset is right, it will be okay. We'll have a model that can do all the other summarization, conversation, everything. So when people start looking at it that way, that is not the original. I mean, it won't be the same way when we start implementing it. Yeah.
Correct. Actually, for our use case, right, we also wanted to generate the text in the lingo of the marketer, right? Because see, for example, if say I'm a Swiggy and a Zomato, right? I mean, incidentally, both are our clients. So it will say that, okay, generate a campaign for lunch, right? With 20% off. Now, if you give this input, most probably, I mean, I'm not going into the parameters and all that, but generally it will be similar, right? Text. But Swiggy and Zomato, notifications, messages are not the same. Now, if you put their past campaigns and tell the model to, generate in their lingo, right? It will give you different campaign text. Right. Now, this can be solved via fine tuning, or this can be solved by intelligent prompt engineering.
Yeah, so let me just flash one slide. So I think maybe I'll just take 1 minute on discussing this. So for folks, so the way to think about this is, bottom to top is where the complexity increases. So what Jacob just mentioned, that let's say you are using GPT, and let's say you have to explain just a simple example which Jacob said, create a FOMO message for Zomato versus create a FOMO message for a Swiggy user. What you could do is at the bottom, the simplest one, you're using GPT-4, it's already a trained model, and you prompt it. Create a answer which is like this. Let's say Swiggy writes more serious answers and Zomato writes Bollywood. So you could say that, hey, create a FOMO message for a user using Bollywood language, and that will be your answer for a Zomato user. And you could say instead, create a FOMO message in a very serious tone. Let's say that might be a Swiggy answer. So that is how, without doing anything without changing anything, just by changing the input that's in context learning. Then you get to the fine-tuned model, which we are discussing right now, where they've taken a Flan T5 or a BERT and then a GPT, and then given it some fine-tuned data, and then trained the model on their own customers' data. Then the next level of sophistication is, you take a GPT and then you train a GPT further, which, for example, Bloomberg GPT did, I showed you. So they were using something called, if I'm not wrong, I think they were using Bloom. Bloom is a data model, LLM. They used Bloom, then they added on a lot of their own data and trained it using that data. So clinical, in this case, this example is using clinical notes to train a medical language data, medical language model. So this is the third. And then fourth is you just start from scratch, right? So you don't use a general text model. You just start completely only with notes. But then, the question is whether it'll be able to understand English well or not. So that is what these are the levels of complexity on which you can go to when you are creating or fine-tuning LLMs, right? So, and then I think for majority of use cases, I think within the first or second one is the preferred. Like if you can get away with prompting, it's great. But generally, to bring in customer context, generally to bring in domain context, you will want to fine-tune the model, is what Naveen, Jacob are mentioning. Anything to add, Naveen or Jacob, on this?
Now, I think, like you correctly mentioned, like most of the cases with intelligent prompt engineering, you can solve, like 80% of the cases you can solve with intelligent prompt engineering. And in fact, for us also, we have developed we have solved the customer language lingo, right, with intelligent prompt engineering rather than, fine tuning. And that saves a lot of cost, a lot of stuff to maintain on the back end. So, yeah.
Awesome. Yeah, Naveen?
I think mostly the fine tuning happens when you have a lot of custom data, right? So you can get away with prompting. Even still, when you have fine tuning the data, you'll need some prompting to understand the context of what the user is going to ask, right? Let's say we have a lot of data sources. We have Notion, we have Google Mail, Docs, a lot of things, right? So when we first search in semantic and send it to a model to summarize it or make it conversational, that has to understand what actually this data is, which date it has been generated, and who created it, so that it can give us a very sensible answer. So the prompting is more important even when you have a trained model with fine-tuning data. So.
Great. There is one extra slide which folks can, figure out later on, which is what we're talking about: prompting, few shot prompting, retrieval prompting. So this is just how to use LLMs effectively. Going forward. So we discussed about, fine tuning or training a model. How did you guys choose the LLMs, right? So between the two of you, you have 4 different LLMs. You have how did you guys come up with which one to choose? How do you decide that? Is there, you just read literature, or you get to know from people, or how do you figure that out?
Literature is the first source.
First was literature. Yeah.
For me, at least, the first source is literature. Basically, look at, how is this problem statement solved by others, right? First, you need to look at that rather than reinventing stuff. And then look at, different approaches and get some benchmarks, evaluate. Then always there is the cost aspect involved, the latency involved and stuff, and the maintenance involved and all that. So you have to look at those factors, before arriving at the final decision, right?
And Jacob, where do you find this literature? So this is more online, or like just Google search, or are there specific places that you would recommend people to go and find?
Yeah, I mean, mostly it's Google, and obviously there are research papers are available, right? So, and various sources, right? So, I mean, I can't pinpoint any specific source, ranging from, some research papers to YouTube to Twitter to, I mean, you have so many. I mean, it's not just one resource has worked all the time, right? So it's multiple.
Naveen?
I think what Jacob said was true. We basically go through literatures, online sources, and then shortlist a few LLMs, and then start trying it out and see with a limited number of data sets to see what. So we know the question and we know what the answer it should produce, right? And then we'll start training it and see how it is. Are we expecting the same thing? Which one is close? And then we identify this model might work better and start investing more and improvising it.
Okay, thank you. Then, while I was talking to you folks, and by the way, you guys are doing LLM chaining. So, is there any special, resource or infrastructure required for LLM chaining? Taking input of one to other, or it's very straightforward with just text input output? Either of you can answer that. Maybe Naveen.
So for us, there was we didn't have much of a chaining, but we had a lot of chunking data, because the models won't allow us to send more than certain number of tokens, right? But let's say you have a huge document with 300 pages of a PDF. We cannot basically send it. That's when we use LangChain and others to chunk it and then create the embeddings and make it work.
Yeah.
So actually, currently we're working on an internal bot solution, which takes not only the support docs, but also the various tribal knowledge, within the organization, right? Whether it be in Slack or some knowledge base or various other places. So for that, we're developing a solution with the help of LangChain and agents to arrive at that. So there will be a lot of, LLM chaining involved and stuff like that, right? So yeah, I mean, and also, vector databases, stuff. So, I mean, that is where this thing will come in.
Yeah, so this brings me to the other next question, which is which vector database? I think Jacob, you guys are using Chroma, and
that is just for prototyping.
Okay,
but at scale, yeah.
Yeah.
So, but at scale, obviously, we'll go for something which is something like closed source, right? Like a Pinecone. Open source, it's fine till an extent, but Chroma is open source, but we don't want to get in the headache of managing everything, right? So at scale works beautifully. Some solution, managed solution like Pinecone.
Okay, so Pinecone provides a managed solution. You're not using it within your AWS cluster, or I don't know whether AWS has started hosting some of these vector DBs or not. But
I think I'm not sure about that. AWS had some recently announced some service, but I'm not explored.
The Amazon, they announced Bedrock. Bedrock
Yeah.
is more for foundation models rather than for vector DBs, is my understanding.
Okay.
Uh,
Okay.
but-
So I'm not explored that, but anyway, I'll explore that once my POC is successful.
Yeah. And Naveen, for you, like your choice of vector databases, how did you decide?
We are mostly in, we store our entire vector database in Pinecone. When we started, we had two vector database in mind. One is Quadrant and other is Pinecone. So Quadrant had it's very good. It's an open source solution written in Rust, which is faster than most of the solutions. But Pinecone has proprietary algorithms and other things which makes it fastest to match and get the data than Quadrant. So we went with Pinecone, and it's pretty good so far. And it can scale up to it can scale vertically without any headaches. As Jacob mentioned, the managing will be the hardest part. And if something goes wrong, at this point, we are not sure how to get backups, update all those things. We are still figuring out all those things. Right? So,
Got it. I think just in the interest of time, there are a bunch of things which are mentioned here, which is like data pipelines, compute costs, measuring performance. I think, is there any one particular thing which you guys found hardest, or which you want to talk about? And then we'll just open it up for group discussion. The last 15 minutes, I want to have people to ask any free form questions they have. So, Jacob, anything which people should be aware of when they're doing fine tuning, other than all the operational stuff which we talked about?
Well, fine tuning is expensive. So that's the
Okay.
first part. Rather not just creating. I'm talking about more so with respect to GPT to begin with. So fine tuning obviously is expensive. Not only fine tuning, but calling the model, querying on that fine tuned model is expensive. Okay, so and even more expensive is right now what I'm trying. With the emotion part, that for us, because it's self-maintained and hosted and stuff, that so we have to use GPUs and all that. So obviously that is so obviously it's expensive. And so when I started with GPT, the text Da Vinci, it was 0.04 cents. And 2 months down the line, it was dropped to 0.02 cents per 1,000 tokens. And then we shifted to 3.5 is 0.002 cents, 1/10 of the cost, right? So the cost of basically intelligence is coming down exponentially. And I was hoping that AWS would also emulate something like that, wherein the cost of the servers, GPUs will come down, but fine, I'm happy with GPT. So I'm saying, this obviously GPT-4 is much more expensive, but for us GPT 3.5 works beautifully. But I think when you have to consider costs, you consider not just the cost of the servers, but also please consider the cost of managing those uptimes and the continuous investment in the maintenance stuff and all that, right? Monitoring and all that. So don't look at just the server cost, right? So yeah, that's from my side.
Thanks, Naveen.
For us, I would say the cost is a factor. It's always there. We cannot avoid it because there is no other models out there which is very good than GPT 3.5 at this point, right? And the other points is, like Jacob said, maintaining a pipeline. Let's say there is some document change happened, we have to have that should also be ready to be searched or available to the user. And if it is manual process, it won't work. You have to have a pipeline which maintains the end-to-end solution. And security and governance is also a part that we have to look into. For us, most of the, let's say there are PI data or any other data which is very sensitive that shouldn't go into the model. We have to clean it before it reaches a search or the model, correct? So those kind of things we have to invest more to figure out which is sensitive, which is non-sensitive. Classifying those things will also have a major role. So let's say we are getting data from Slack, we are getting from Jira, Confluence. There will be a lot of usernames, password, test data, all those things will be there. Right? You cannot just push that to LLMs, or we can not just push it to the Pinecone DB. So we have to clean all those things before it goes. So that we have to look into those things as well when we design a solution.
Yeah, I think even in data science problems, it always existed that, right? So
Also, for the folks, viewers, basically, please, for APIs, the default is they won't use the data for their training, GPT. But if you use it in their UI, by default, it goes into training.
so if
Training
you
that
use
data.
the UI, okay, if you use the APIs, it doesn't go into their training?
No, by default, it doesn't go unless you expressly said that you can enrich your, training data.
But when you use GPT, the UI, the website,
By default, it goes into
wow.
enriching that data.
Is there some way? That's why I trained it so much in telling it that I am Priyank Swaroop, that it was arguing with me.
Okay, yeah, probably.
Is there some, Jacob, do you know, is there some way to switch off the database, even through the website, the data?
I think there is, but I have not explored that because I have never touched the UI a lot. It's only for, basically time pass purposes.
Okay. Fair enough. Naveen, you were saying something?
I don't think there is a way we can turn it off. Because that's when if you're asking the same question and if you're training a certain data, it will learn it from that. And if you give a different answer, when you go back yesterday, it didn't give you an answer. Today, it will give you a new answer because it learned from you.
Yeah. All right. So fun stuff. So guys, 15 minutes left. I'll stop the presentation at this point of time. Thank you, Naveen and Jacob, for answering a lot of questions. Please stay on. I think people will ask more questions. There were 2-3 questions which have been asked. And maybe I'll start off with, since both of you are there already, which is, the question has been asked by anonymous attendee, which is, there is a lot of content available around people trying to different use cases, but there's structured learning around these topics, LangChain, Llama Index, models and prompts, which allows internal teams to create applications. So how do you train your teams? Like, do you have teams, or like, how did you guys pick up? Can you talk a little bit about it?
Okay, on GPT, you're asking specifically?
Yes, I mean,
the applications on GPT?
Broad. Question is, I think, broad. Like, how do you, let's say, LangChain, if you want to learn and solve a particular use case, so what is the right process, in your opinion, of learning?
Okay, LangChain it itself, if I'm not mistaken, 3 or 4 months old. So obviously there is a dearth of structured, learning. But I'll just one channel I'd like to paste. I mean, if you quickly want to, build some application, right? So James Brigg, it's very good. So even I tried the initial version with this code that he uses. So he has code as well as explains it very well. So I think you guys can, because most of us are beginners, right? So you can try this out. So he has gone through various levels of complexity, right up to the agent level. So just check this out. But yeah, I mean,
yeah, I'll just post it for everybody. 1 second. So this is the channel which Jacob is recommending. Naveen, anything from your end?
So there are it's rapidly changing, right? Even in LangChain, there are agents, things coming on very soon, right? So what we did was we went back to the team and said, okay, let's learn from the basics first. Let's learn what is out there for a long time, right? Once you understand those basics, then we can go back and say we can play with the models and other things. We spend a lot of time understanding what embedding is, how a vector database works, how do you learn prompting, how do you chaining and chunking, all those things. We started asking the team to learn, and we asked the team to teach each other so that it will be a team effort to learn. And then we went back and started learning what the LangChain is. And there are it's rapidly changing. So even if you use a LangChain version today, in next 2 months it will be changing, right? And there's a lot of breaking changes. So in that case, we wanted to try it out. Still keep an eye on what is happening in the new things as well.
Yeah, I mean, our experience at Axel has been very similar to Naveen's and Jacob's. It's a lot of new stuff which is happening every day. The speed at which this is moving, if you want to adopt and learn, as a talent. And so what we have done is, like, I hold, brown bag lunches once a week. We get together 1.5 hour. People learn on new topics and discuss it. This is something which is new. So that is one thing which we do. Second, of course, all of you are there on the, a lot of you are there on the group. Maybe I'll just flash it for you guys. So this is the, if you guys see my screen, this is the Everything AI Axel group. And please use this for sharing papers, sharing topics, sharing YouTube videos. There are already some discussions happening on it. And I try to post any meetups which are happening, any hackathons which are happening, anything interesting which I have learned here. I would request all of you to share as well. All of us are newbies, so no question is wrong. Nobody is judging anybody. Please ask those questions. Second is, I would recommend one other channel for just starting off. If you're starting off on LangChain, this is how I learned LangChain. So I'll post this particular resource. I found it very useful. This is Data Independent. He has this playlist of
Hello, good.
Going through what is LangChain and 101s, and he walks through a bunch of tutorials on this, how to use LangChain to query YouTube transcripts, finding Google Drives, connecting to agents, all of that. So I think this has been quite useful for me. So I'll post the link here, essentially. Thanks guys for that. One question which was asked for anybody who's working on Stable Diffusion, if you would like to answer, are there any questions particular, like, has anybody fine-tuned a local Stable Diffusion model here? This is more on image gen, so slightly shifting gears, essentially. Would anybody like to answer that question? All right, Sumant. Okay, Sumant, awesome. You're on screen. So Sumant, the question is, has anybody trained? Yeah.
Obviously, it's not about training, but given that Stable Diffusion has, and of course, Midjourney too has so many different styles. So sometimes you want to maintain the consistency of the styles, right? So in that case, you have to you have to build different pipelines, which again you can do with smart prompting. If you experiment enough. But yeah, basically, you want, let's say now you want to do something for a specific customer. You want to keep everything consistent, the styles consistent. So obviously, in the art kind of world, you can really do whatever you have. You have all the degrees of freedom to experiment. But when maybe in a more business use case, you want some consistency in and the quality of the photos and images that you generate. So in those kind of cases, you need to build different pipelines and you need to experiment with that. So we have done quite a bit of that.
Thanks, Sumant. Also, yesterday night, there was this talk on Stable Diffusion AI hackathon, and which discussed advanced Stable Diffusion techniques. I'll post this YouTube video on the group. So, you guys can look at it and hear by the way, the person who gave the talk is from Bangalore. I can ask him if he would like to give a talk on Stable Diffusion to all of us. And he talks about how do you mix 2-3 different stable diffusion models and checkpoints together to come up with a particular answer. So you get stylistic images. So in this particular case, he showed like 2 models. Let me show you guys. So stable diffusion allows you to mix different art types, right? So this is the one model which I showed you today. It's called Deliberate. And there is another model. So taking some of the images from here, style from here, and then combining it with another model. Sorry, this is just working very slow today, the Swift AI, for some reason. Let's say you want to combine it with one other model, any of these comic models. So he shows an example of how he combined that model with comic diffusion models, so that you get like almost manga style realistic images, or and it's a nice video for you to watch, essentially. So that is one. By the way, image training fine tuning is very, very expensive, much more expensive than so people have come up with something called LoRa. This is a technique to train fine tune models, and people can explore that. One question which Jacob has already answered is Arnab had asked, is fine tuning differential pricing is available for India versus US? The answer is no. Today everything is at the same price. So by the way, AWS has launched AWS Bedrock, and we will call them to see if they are going to provide this differential pricing, because AWS has differential pricing everywhere, and you can use stable diffusion and Anthropic and some of these others using AWS Bedrock. I don't know what the pricing will be. Hopefully it's different, but GPT-4 has the same, or GPT 3.5 has the same pricing everywhere. Yeah. Guys, open conversation for anybody to ask any questions, please. So we have 4-5 minutes more. Sorry, we took a lot of time. So any questions on this? And meanwhile, I'll just open the poll. Please help us with that. So the intent is for this session is to basically, we will want to do more of these sessions. So I'm just going to make a poll live. Please let me know, should we do more of these and the intent will be to do more and more. And then anybody who's mentioning no, please let me know. My email is priyank@axel.com. Why? I hope it's not my team who's pranking me, but the intent will be next week. I'll maybe on the group, I can on the Everything AI group, I'll ask what topics will people want. So looks like LangChain and stable diffusion seem to be 2 interesting topics. So we will see which one we can arrange a webinar on for that. So that would be what we will try to do. If no more questions from anyone, we can close. Thank you for all of you who stayed long. This 2 hours online is not easy. I really appreciate you guys coming online. And there's one more question. Is it okay? What's the question? Is okay. All right. So people feel free to jump off, but I can answer this question, which is Arnab is asking, when you said combining models, so at least in stable diffusion, what you can do is, and there's sorry, just give me 1 second. I'm also going to post. 1 second. Just hold on, guys. I'll just showcase you the all of you. Thanks for joining, and you can all scan this code, QR code for joining the group. And to answer your question, Arnab, stable diffusion allows you to basically mix 2 models. It's like mixing 2 colors, mixing 2 styles. So you can say take 30% of a photorealistic model and 70% of a comic model and combine the 2, and then you can see what kind of output you get. right? So when you go look at Civit AI, you will find people have created different models by combining different kind of image types, image models. So somebody will train their image on, somebody will train Stable Diffusion first on manga comic images. And then somebody else will basically say, okay, that's great. I want to train it on, let's say, oil paintings of Picasso. And then you will get two different fine-tuned models. What Stable Diffusion allows is to then combine those two. So combining is basically you take almost like a weighted average of two models. So the weights will get multiplied and you will get a final output, which will be different from the initial one. So that's what it does. Okay, so Sumant, I'll connect you guys. So if you want to connect to any one of the people here, and Joy, just please, Joy is asking to talk to Sumant. Just message directly or on the WhatsApp group. He will be there. So Arnab, I hope that answers your question. Right, but I think it will be good for you to watch the video. It's Stable Diffusion is a lot of fun. You know, and one way to use Stable Diffusion, by the way, is sorry, I'm just jumping here. So I think there's Dream Studio. This is you can go to beta.dreamstudio.ai. This is the Stable Diffusion model. This is Stable Diffusion hosted by them. I just pressed the wrong thing. Too many. So here, this is Stable Diffusion's online version, which they have put. And you can see here, like, there's a prompt, right? So you can say futuristic Earth landscape or Mars landscape, for example. So I can do this and then click on generate. Though this is a paid version, right? So you have to pay money for this. I have some 1,000 tokens, which I have, and then you can get some models, and then you can improve the settings and do a bunch of things. And so for give you some sense, it's like 1,000 credits is 5,000 images. So 1 credit is so that's the way it works. Okay, one more question. Okay, cool, awesome. Yeah, folks, that's all we have for today. So thanks for joining, and we'll end. And thank you, Jacob and Naveen, for taking out the time. It was an amazing chat. So please, thanks.
Thank you for having us. It's a wonderful initiative, Axel. Thank you.
Thank you, guys. Bye.
Thanks.